Hey guys, this video is going to help you with the application style problems for SOHCAHTOA. Using our trigonometric ratios, we will be able to solve actual, like, real world kind of problems. And I know, some of you are like, well, I'm not solving those problems in the real world. Well, you could if you wanted to once you figure this stuff out. So that's the basic idea. We're just going to use trig ratios, but we got to get good pictures. So first things first, let's look at the first problem. And this one, we were able to get through in class, but for those of you that weren't here, this may help. And even if you were here, it probably can't hurt to see it again. So, excuse me, you've got a ramp that leads up into an airplane. The ramp has a 31-degree angle of elevation. The horizontal distance from the beginning of the ramp to the plane is 30 feet, and they want the length of the ramp, and they want the height to the door. So, why don't you pause it, try to draw a good picture, and then replay, hit play, and then see if your picture matches mine. Okay, so hit pause, draw a picture. You don't have to solve anything yet, just get a good picture. Okay, so pause. Alright, so let's get a good picture of this, and we have an airplane, okay. As those of you that were here today, you saw my drawing skills are not the best, but at least gets the point across. So there's my airplane, and there's some kind of door of some sort to get into the airplane. There's the cockpit, and we got some kind of ramp. And the ramp is supported so it doesn't fall over. And there is our setup. So there's our picture. And we have to assume that, the airplane and the door is vertical to the ground. And, perpendicular to the ground. And then you've got the ground here, and then this is your actual ramp. Okay? Let's just go back. Let's look at the numbers that they gave us. The ramp has a 31-degree angle of elevation. Okay, so that's going to be right here. Again, the angle of elevation, you know what? You can't see that too well. I'm just going to redraw that triangle a little bigger so you can see it. So this triangle right here, I'm just enlarging. So here is the ramp. I just noticed that it's kind of small on the screen there. So here's the 90-degree angle. And then all I was saying was, here's the 31-degree angle, the angle of elevation, because we always build the angle of elevation off of the horizontal and go up. How many degrees does it go up for angle of elevation? Angle of depression would be from the horizontal again, but it'd be how many degrees does it go down? And then that would be the angle up here, which I don't really need to draw. Technically, it'd be right there. And of course, those two are the same, because those are alternate interiors. So we did talk about that in class, but just, I guess that's good to know because they could just give you the angle of depression. But for this one, it is just angle of elevation, so it's right here. But again, they're the same thing. All right, and then they told us that it's the bottom of the ramp is 30 feet horizontally to the plane. So 30 feet would have been here, but in the bigger triangle, I'll just put it over here. And then each part, they say, okay, solve for the ramp. And then it says find the height. So just do one at a time. We want to find the ramp. So the angle is 31, and I need to label my picture so I know what pieces are what. If I'm going to use this angle here, well then this piece has got to be the adjacent leg. And then the side across would have been the opposite leg. And then of course the hypotenuse is always the hypotenuse no matter which angle you're using. So I need the hypotenuse. I know the adjacent. I still don't know the opposite leg, and that's part B, right? If you look at the question again, part B says find the height. So I'm just going to pretend that's not even there. What is the length of the ramp? So I'm just focusing on the length of the ramp, which is the hypotenuse. So I need to use the 30 feet, which is the adjacent, and I want to try to find the hypotenuse, which is my x. So I need adjacent with hypotenuse. Which one of these uses adjacent with hypotenuse? Okay, that's got to be your cosine, adjacent hypotenuse. So the cosine of 31 degrees must equal 30 feet over x. And then now it becomes a calculator problem like we've done so many times. The hard part is just getting a good picture. So cosine 31, excuse me, is I got 0.857, let's say 2. Equals 30 over x, and then I've said this many times. If you watch the other videos, it's going to sound like a broken record because this is where some of you still get tripped. try to play it safe. If you're having trouble knowing when to multiply and when to divide, play it safe. Put this over 1 and cross multiply, and you'll never make that mistake. The 0.8572 actually goes with the x, equals 30 times 1, which is just 30. So we're not done. Okay, we're not done yet. The answer can, we have to solve for x, so we got to divide this by 0.8572. So x is going to be approximately, those cancel, 30, that's an 8, 30 divided by 0.8572. And you get about, that's pretty much 35 feet. And there's your ramp. Now we still got to do one more thing though. We still need to find the opposite. So at this point, you've got the hypotenuse. I suppose you could just use the 35 and use whatever ratio would involve the 35. Or maybe even use the Pythagorean theorem. Those are not bad choices, but for the sake of practice and accuracy, because in case I mess this up, I'm just going to use the numbers they gave me. I'm still going to use the 30, and I'm still going to use the 31 degrees, but this time I'm going to try to solve for y. And I got to say again, which trig ratio lets me solve for y, which is the opposite leg, knowing the 30, which is the adjacent leg. So only one of those ratios is going to use opposite with adjacent. That's opposite with hypotenuse. This was adjacent with hypotenuse. We already used that. Ah, there it is. Tangent is opposite over adjacent. And I want opposite with adjacent. So here we go. Tan 31 degrees equals opposite divided by adjacent. And then here we go again. Same exact principle. Do you know to multiply? Do you think you're going to end up dividing? Do you want to get tan 31 now? Do you want to do it later? Whatever. Take your pick. Whatever works for you. I'm going to do it in the way I think is the easiest for most people. So tan 31, let's see, that's 0.6008 or 9, depending on how you round it, equals y over 30. And then I'm going to cross multiply again just to play it safe. And this time you can see it works out kind of nicely, because when you multiply y by 1, you just get y. And then 30 by 0.6009, well, whatever that is going to be my answer. So times 30, and I get, looks like it's just over 18, 18.0302, something like that. So 18.0, or just 18 feet. And that's what you do. You look at the problem, you sort of translate it, from words into a picture, you label what you can, and worst case scenario, you put a number in the wrong place. Okay, but you still get most of the credit, but hopefully you'll be able to tell what they're trying to get at. All right. So that's the first one. I will make another video of the other ones. I'll do them a little quicker now that you have the main idea, and so look for those soon. Okay, if you have any questions, obviously post, and I will do my best to help you out. Okay, see ya.